Welcome back. This week, we're going to finish up the legs on the shop-made dividers. The drilling operations were performed on the Kasuga knee mill with a centroid control in a vise that was turned on its side. Here you can see the part being snugged into the vise and the operators starting it from the pendant. This is the view of the control, the operator's view. The spindle starts and the drill lowers into the work, drilling the hole, and then quickly retracts and the spindle stops. Please wait for it to stop. After drilling, all that's left is to slit the clamp and to put in the 632 thread for the thumb screw. Before we get started, let's talk a little bit about slitting saws, or jeweler's saws, as they're sometimes referred to. It's a saw that's used for making very fine cuts in a variety of materials, from metal to plastic, steel, aluminum, brass, etc. This is an example of a typical slitting saw operation where we're slitting a clamp on the CNC mill. While building the original prototype divider's compass, I needed a slitting saw to make the fine cut, and I figured about 20 thousandths of an inch would be about perfect, and I didn't have one on hand, and so I took a 50 thousandths thickness and reduced it on the surface grinder to 20 thousandths. Normally a slitting saw would be hollow ground, meaning the center would be a little bit thinner, but this one proved to work out really well. So it worked on the prototype, we're going to use it. The final machining of the leg consists of three operations: a drilling operation, a tapping operation, and a slitting operation. We're using a 3/32 end mill to do the drilling and the clearance hole, followed by a 632 tap, and finally the slitting saw. During the design of the fixture, I found it helpful to create a sketch representation of the slitting saw and the corresponding arbor to ensure that as it followed the tangent of the lead, it wouldn't collide with the fixture or the work. Machining the fixture from the maple was really easy. Used a 3/8 end mill to pocket out the work, and then contoured the face to finish it off. I then drilled and tapped for 1032 screws. The form tap I used, which is what I normally would use for aluminum, didn't give a fantastic fit, but the threads are holding up. I only have about 100 parts to do, so hopefully it'll be okay. I then came back and chamfered each of the holes and chamfered the edges, kind of cleaned it up, and turned out really nice. I didn't think to film the making of the fixture, but here it is with the part installed. It looks pretty good. The first run on any new setup always makes me a little bit nervous. You have, generally new tools, new setup, new fixtures, new things to run into. The hole went in fine, everything looks good. It came in and tapped the 632 hole with the gun tap just fine. The slitting saw came in, made its cut, worked perfectly. This ran without any issues. I'm very happy. I'm happy with the overall results, so let's run some parts. I changed the camera position to hopefully give you a little bit of perspective from the operator's viewpoint for both installing the part and running the part. So here you can see I'm placing the part in the fixture. Select tape mode, press start, and verify the ready light is on. On the CalMotion USB, select the file, press start. Here's the full operation sped up for brevity, but to give you an idea of what it looks like, including the tool changes, this is the full run. This is what the operator would see standing in front of the machine. Operator's control panel with G-code running. And once again, we finish up the operation with the slitting saw. The progress on the shop-made dividers is coming along. Up next, finishing the dividers. Thanks for watching.